Okay, so right now we will be discussing aircraft performance. We'll be looking for how we can find our crosswind and headwind components. So we have our chart here. We have the wind component chart, whatever you call that, and we're going to be looking at our problem. The surface wind is 180 degrees at 25 knots. What is the crosswind component for runway 13? So when you're looking at your crosswind component, the crosswind component is here. So you'll be looking at these numbers when you want to look for your crosswind component. For your headwind, you'll be looking here, but for now we'll be looking down here. So first you need to identify what is given. So the surface wind is at 180 degrees at 25 knots. What is the crosswind component for runway 13? Alright, first what you need to do is to get the difference in the angle. So since you have runway 13, that would be 130, and you have 180 degrees, you have 180. You're going to subtract the both, which will lead to 50. You don't have to bother with this sign because you just need to subtract that. So that's 50. So you look at your chart here, take a look at your chart, and this is 50 degrees. So this is the difference of your angle between the surface wind and the runway. Next, you'll be taking a look at 25 knots. That will be your surface wind, which is the arc. So look for 25 knots and look at the arc. So this is your 25 knots and this is your 50 degrees. You'll be looking at where these two intersect. So this 25 and 50, this is where it intersects. Now you're looking for your crosswind component, so you will align that to the bottom and see which indication it is. So since you have 0, 10, and this is 20, each increment is 1. So this will be 19. So your answer for this will be 19 knots. Okay, moving on. It's the same thing for your headwind component. So we have this problem now. What is the headwind component for runway 13 takeoff if the surface wind is 190 degrees at 15 knots? First, you need to write down your given. So we have runway 13. We have wind is 190 degrees. This is our heading of the wind, and then at 15 knots. Runway. Okay, so first you need to get the difference between the angle difference between the direction of the wind and the runway in degrees. So we have our 190 degrees and you have your runway 13. You subtract that, you get 60. So look at your chart, check which angle is 60. So again, this is your angle, this is your surface wind in knots. The arc is the surface wind in knots. Now, since you have your angle already, you look at the speed in which your surface wind is, which is in our case 15 knots. You look for 15 knots, which is right here on this arc specifically, and then you look for 60 degrees, which is this angle. Then you look for where they intersect. So they intersect right here, and since you're looking for headwind, you look at this specific area. So we are at around 8 around 8 knots. That will be our answer now. 8 knots of headwind component. Okay, so moving on to our next problem here. Determine the maximum wind velocity for a 30-degree crosswind if the maximum crosswind component for the airplane is 10 knots. So as you can see, we only have 2 given, and we're asked to be looking for our maximum wind velocity. So in order to find our maximum wind velocity, you'll have to look at which arc it represents. So which arc it will be. That's what we're looking for. So let's write down our given. Our angle is 30 degrees crosswind, and our crosswind component is 10 knots. So this is straightforward. As you can see, this is 30 degrees, so we'll look for the angle of 30 degrees. This is 30 degrees, and then our crosswind component of 10 knots. What you'll do now is you look for the point in which these two intersect. So 10 knots and 30 degrees. 30 degrees, 10 knots here. So you will then take a look at which arc it also intersects with. So it intersects with this arc, which is 20 knots. So your answer will be 20 knots. So we have our last example here with a reported wind of south, which is 180 degrees correction, at 20 knots. Which runway? We are given three options: runway 10, runway 10, runway 14, and runway 24 is appropriate for an airplane with a 30 knot maximum crosswind component. So we are asked to look for our runway, and in this problem we'll write down our given, which is south being 180 degrees, 20 knots of surface wind, and we have our runways, which is runway 10, 14, 24, with our crosswind component being 13 knots. So what you want to look for first is your surface wind and your crosswind component. So take a look at your surface wind, which is this surface wind or wind velocity, and look at the arc. This is going to be your arc because 20 knots. Okay, next take a look at your crosswind component. So since this is 20 knots, you look at your crosswind component. You have one. You start from 10, and you count 3 increments. 1, 2, 3. So this is your surface wind. Correction, your crosswind component. So since that's 13 knots, you will then look at which point intersects with your 20 knots of wind velocity, and then you'll take a look at which angle you intersect with as well. So since you intersect with this line, your angle is 40 degrees. So now we have determined that we have 40 degrees in difference between angles in the angle of our runway and our wind direction. So let's take a look at our degrees, which is this 180 degrees, and then we will now subtract or add 40 to see if we have it in our runway. So if we add 40 to 180, we have 220 degrees. And now let's take a look at our runway options. Do we have any runway 22s? We have runway 10, runway 14, runway 24. We do not have runway 22. So let's subtract it. Minus 40, which is 140 degrees. Do we have a runway 14? Yes, we do. We have runway 14. So our answer is runway 14.